Smell like running.
Okay. So, this is the backside of the 1-6 notes. So here we go. Using substitution and elimination. You people, I'm going to change the first problem up there because I don't like it very much. We're not going to use our calculators to solve this yet. So I'm going to change the first problem, and I'm going to call it, I'm going to do this. Negative 9c minus 4d equals 31. And 9, let's change them to x's, okay? 9x 4y. How about that? Can I do that? Sorry.
Wait, why are we doing this again?
I'm changing the problem. 6x blah, plus 6y equals negative 24. Woo! What? It is a 31. I'll put this thing up here so you can see it a little easier. There you go. That's what I want. That's what I want my first problem to be. There you go. So we're going to change this. We're going to make that the first problem. Sorry for the yes, except our x's and y's. It doesn't really matter if we call them c's and d's, but just for the first time, it might confuse you if they're not x's and y's, right? Okay. Okay, beautiful. All right. Now, we are using the substitution method. Do you know what it means to substitute something? Like you plug it in, right? Okay, so I want to solve these two equations, and remember that these are two lines, right, that are existing somewhere on a coordinate plane. We are trying to find what? Where do they cross each other? That's all that we're interested in. Where they cross each other, okay? So the method that we're going to do right now is called substitution, right? In order to be able to substitute, I need to plug something in. Plug in. So I'm going to take one of the equations and plug it into the other, right? But in order to do that, I have to have one of the equations have something solved for, right? It can't be just the whole darn equation. I have to have solved one of the equations for x or y, right? So what I want to do is I want to, first and foremost, choose a variable to solve for. That's number one. Choose a variable to solve for. And I almost think this is the hardest part. After you've done this, it's pretty well easy, but choosing your variable to solve for, if you choose a variable that makes some really nasty fractions, it can really confuse all your steps, okay? But if you choose a nice variable to solve for, where it has nice clean numbers, then it can make your life really easy, okay? So for example, let's say that I'm trying to solve for this x right here, this top x, okay? Don't write any of this down, right? If I'm trying to solve for this top x right here, okay, I would add the 4y to the other side. Don't write any of this down. Negative 9x. I would add the 4y to the other side, right? So I have equals 4y plus 31. Make sense? Yes? Okay, and then what would you do to continue solving for the x? Divide by negative 9, right? But does 4 divided by negative 9 or 31 divided by negative 9 come out really nicely?
No.
Yucky. That's not very nice, right? Is there a different variable that we could solve to make it really nice?
No.
Let's do the 6's at the bottom, right? Do you want to solve for x or y? Because both of them are 6's.
Why?
Y? We're used to solving for y, right? We're used to solving for y. So let's do this. Now you can write. Let's solve for this y down here, right? In the second equation, we're going to solve for the y because everything's divisible by 6. 6, 6, and 24, they're all divisible by 6. We have really nice numbers then, okay? So this y is what we're solving for. Let's kick the 6x to the other side. All right, so I have 6y is equal to, then what? Negative 6x minus 24. Okay, and then we're almost done with that. Divide by 6, divide by 6, divide by 6. So we get y is equal to negative 1x, or just negative x, minus 4. Okay, now the hard part is over. Everything is going to be fairly easy from here on out, right? Fairly easy. Okay, I know that y is equal to this junk. That is what y is. Y is that stuff, okay? And that I got from the bottom equation. So what I'm going to do is this y right here, I'm going to replace this y right here with that junk, right? All of that junk is going to get shoved into y in the top equation. Because I solved the bottom equation, I've used the bottom equation already. I'm going to use the top equation to plug my stuff in. So negative 9x is going to stay the same, yeah? Negative 4y is not going to be y anymore. So I'm going to put a big long parentheses equals 31, okay? You see my top equation? I have him ready to go, but y, I have a big blank because I'm going to shove this stuff. Times negative x. What does that make? Plus 4x, okay? And negative 4 times negative 4? Plus 16 equals 31. Okay, now I have it kind of nicer. Okay, let's do one more thing first. What can we do first before we minus the sign? Combine the x's. Negative 9 and 4x. What's that make? Negative 5x. Okay, plus 16 equals 31. Okay, and then what? Minus the 16 minus the 16. Negative 5x equals 15. They're ahead of us a little bit. Divide by negative 5, divide by negative 5. What's 15 divided by negative 5? Negative 3. Okay, circle that guy. Now, do you see where this gets kind of confusing? Those people who have really crappy handwriting. That's not terrible. Those people who have really crappy handwriting. It's hard. Jason, let's come back over to Jason. It will get kind of muddled because there's lots of steps, right? It will get kind of muddled. So write nice and neat. Make sure that you can see where all your thoughts are, and we're good to go. Are we done? No. Now what do? Plug it back in. We want to find y now, right? Okay. Where do I plug it back in at? Wherever you want. So I could plug it in here, or I could plug it in here, or where is it really nice to plug in? Right here. Can I plug it in right there? You bet I can. Oh man, that's really nice. Y equals negative x, and x is negative 3, minus 4. I just plugged this guy into there. That makes it really nice. Yeah? Yeah? Okay. So minus a negative 3 becomes positive 3, right? Minus a negative is positive. Y equals negative 1, they said. Okay? Done? Here's what I want you to do. When you're when you're to the very last step, you're going to write your answer as an ordered pair. You know what I mean by that? Yeah. Okay?
1, negative.
Negative 3, comma, negative 1. Okay? This guy. And that is your final answer. And why do I care about that point right there? That's where the two lines cross each other. That's a quiz question I use a lot. Okay? Why do I care about that point? Because those two lines cross there, right? Negative 3, negative 1. Perfect. Okay? That does take the more you do it, the faster it goes. I was going really slow. Okay? And it takes up a lot of space. Okay, write out all your work though and make sure it's nice and clean, okay? Good? Do we want to do another substitution before we go to elimination? No. Have you guys done this last year? Probably. So. You think so? It looks familiar a little bit, okay? Okay? Should we do one more? We have to do one below here. Would you like to do one of these with substitution and elimination? No. No? Okay, now, substitution is not my favorite method. My favorite method is elimination. I like to eliminate things, okay? When you eliminate, you're basically making this a big old addition problem. You're adding those together, and you're doing that stuff, right? Okay, you're adding those things together. Now, if I add the x's together right now as they are, 5x plus 8x, that will make 13x, right? And if I add 3y plus 3y, that will make 6y. So none of my x's or y's cancel out. What I want to have happen is I want to change the equation in some way so that either x or y will cancel out. So which one can I cancel really nicely? The y, the 3's, right? I can cancel that 3's, but what do I have to do?
Make one of them negative.
Make one of them negative. Which one do you want to make negative?
The bottom.
The bottom one? Sure. So if we make the bottom negative, if we multiply him by a negative 1, right? The top one's still going to stay 5x plus 3y equals negative 19. I'm just going to rewrite him. Okay, he's just coming straight down. But if I multiply that other one through by a negative 1, he will become negative 8x minus 3y equals positive 25. Does that make sense? Okay, now I add them. I add them together. So what's 5 plus negative 8? Negative 3. Negative 3x, okay? 3y plus a negative 3y? goes away, so they just cross out. So I'm just going to cross them out, equals negative 19 plus 25. 6. Positive 6. And then divide by negative 3. Oh, I'm running out of room. Divide by negative 3. So x is equal to negative 2. Negative 6, or excuse me, 6 divided by negative 3 is negative 2. Circle him so you can find him later. Okay? And now we have to substitute in. That was really nice getting to that point. A lot less work. But substituting back in is going to be a little bit more unpleasant, right? Because we don't have any of the equations really nice and solved for. Okay? Which equation do you want to plug back into? First one, it doesn't matter which one you plug back into, okay? Just make sure you're plugging in the x and not the y. So 5 times x plus 3y equals negative 19, and x was negative 2, so I'm plugging him in there. Do you see how this works? Plug him back in, okay? And now what? Now what do I do?
You multiply the 5 and
5 and negative 2 is negative 10, okay? And then what? What? What do you want to do next? Plus the 10 over, yep. Add the 10. Plus 10. So 3y is equal to negative 19 plus 10 is negative 9. And then divide by 3. Y equals negative 3. So what's my answer? Negative 2 comma negative 3. And why do I care about that point? It's where those two lines cross each other. Okay, now, just a little tidbit. I will never, ever, 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 ever on a test or a quiz have these answers come out as really nasty, ugly decimals, just FYI. So, if you do this problem on a test or a quiz or something like that, and you get a really nasty, ugly decimal, you're wrong. You did something wrong. Go back to your steps and check to see what you did. Okay? You're wrong. So, there's that. Okay, now, yesterday we had the scenario. Not always did we get one solution where they crossed each other, right? One solution would look like this, where my two lines are crossing each other and we're finding this guy. But sometimes we didn't get one solution, right? Sometimes we got no solutions. And what happened when you had no solutions?
They were parallel.
They were parallel. So this is one solution. One solution. If you have two parallel lines, there is no solutions. Okay? And if it's one line solid, there is infinite solutions. Okay? Now, we're not graphing these problems if we're doing substitution and elimination. So how do we determine which ones have no solutions and which ones have infinitely many solutions? You've solved them just like normal, but you're going to get to a dead end. Okay? And I'll show you what that dead end looks like. Okay? You're going to do a dead end on each one of these. So no solutions and infinitely many solutions. You're going to treat them like normal. Okay?
How are you supposed to know if, like, the one that we just solved, like example 5,
What?
how are we supposed to know if we just graph that?
If you're supposed to graph it or not, you're not graphing these.
I know, but
We're finding the answer without graphing. What?
wait, so on any of these?
Any of these you're not graphing. This is an
No, but
alternative to graphing.
The stuff we did yesterday, we didn't have to graph it, we could have solved them like this.
They could have been solved like this, but they wanted you to graph. Every single problem can be solved using one of these methods. You don't ever have to graph ever again. I know, I'm sorry. I've been deceptive up to this point. Sorry. You don't have to graph anymore. But now you know what it looks like, right? Now you know what it means to have one solution, blah, blah, blah. So what does it look like using algebra if it has no solutions or infinitely many solutions? You treat it like normal, but you're going to get to a dead end, and I'll show you what that dead end looks like. So let's do these. So in part A, we get to choose. Do you want to use substitution or do you want to use elimination on this guy? Look at your numbers that you have.
You want to use elimination.
Elimination. Okay, so if I add the x's together, they want to use elimination. If I add the x's together right now, I have 20x, right? If I add the y's together right now, I have 12y. None of those cancel out.
So then you want to do substitution.
No,
No, you want to
no, I just have to change something. Okay, if I take the first one times 3, that will make this guy 9, right? And this guy 9. But they still don't cancel out though.
Negative.
You have to multiply him by negative 3.
We're going to have nothing.
Okay, if I multiply him through by negative 3, if we think about what the y will look like, that will be negative 9, and then the y's will cancel out, right? So right below this guy, I'm going to distribute him through. Negative 3 times 5y, or 5x, is negative 15x. Okay? Minus 9y equals negative 3 times 52 is 156. That's a big number. Negative 156. Okay? Make sure that you have your negatives attached, right? If you get a really funky wrong answer, sometimes it's because you drop your negative. Don't drop the negative, okay? I'm going to write the other one right below it, just so that we have it. 15x plus 9y equals 54. Okay, are you ready? Are you ready? No. No. Oh, no.
It equals no solution.
Oh, no. Okay, so let's look at this. Negative 15x plus 15x. Negative 9y plus 9y. So what's over here on this side? Nothing. What is it if it's nothing? 0. 0 equals, okay, what's negative 156 plus 54? Negative 102. Okay, so right here I have 0 is equal to 152. When does 0 equal 152?
If there's an x, that is
But there's no x. 0 is never equal to 152. This is no solutions because 0 does not ever equal 152. So this is no solutions. If I would graph those two equations, what would it look like?
Yeah.
If I would graph those two equations, they would be parallel. They would not touch. They would be parallel, right? Okay, but I can figure that out without actually having to graph them, right? That's so super awesome. Okay, part B, let's see what happens here. Would you like to use substitution or elimination on this one? Okay, so I have 2x and I have negative 4x. And if I add those together, they don't cancel out. And I have 3y and negative 6y. And if I add those together, they don't cancel out. So what would you like to do? Yes.
Change
multiply them by 2.
Multiply the top row by 2, I'm hearing. Okay, so let's try it. Negative 2?
No.
That would make it negative 4x, and then the other one's a negative 4x. So those won't cancel.
No.
One's got to be negative, one's got to be positive. Okay, so let's do positive 2. So 2 times 2x. 4x, it's right there on the side. Girl, okay. Grab it in the water bottle. On the corner. There. You might have to dig in that high. Nope, closest to you. Yep. 4x plus 6y equals 2 times 15? 30. Okay, now I'm going to rewrite the second one. So negative 4x minus 6y. We did not change this one. Let's add them together. Okay. What's 4x minus 4x? Goes away. 6y minus 6y. Goes away. So what do I put on this side? 0. 30 minus 30 is 0. Now, when is 0 equal to 0?
Never.
Always.
Never.
0 is always the same as 0. 0 is always the same as 0. Infinite solutions. Okay? When you have two things that are equal on both sides of the equations, like 2 is equal to 2 or 0 is equal to 0, blah, blah, blah. Everything cancels out and you have those two numbers and they're both the same. There are infinitely many solutions. If I were to graph these guys, what would they look like?
On top of each other.
They would be on top of each other. They would be the same line. Does that make sense? So when you have weird things happen, like this or like that, you're either going to have no solutions or infinitely many solutions. So if you have two things that are not making sense, like 0 and negative 102, that's no solutions. When you have 0 and 0, that's infinitely many solutions, okay? You have 8 homework problems. 3 of them are substitution, 3 of them are elimination, and then 2 of them are like funky weird. They tell you which one to do by substitution, which one to do by elimination. They tell you which ones. Yes.
Can I
What?
If it like starts with a y, like you don't have to do it.
Then you just substitute it in.
Are you gonna
Then you get to skip the first step.
Are you gonna stop screen recording?
It's like y equals something and y equals something. Just plug that answer in and then it equals the other one.
What? That makes no.
Yes, it does.
All right.
I don't get it.
Hold on.
It's
Let me stop.